force over area is equal to the stress. It's a basic equation. So that means that force is equal to stress times the area. And we're going to sum the forces, make them equal to 0. So we have to calculate the forces that are summed up in this here, in this hoop direction. So there are two forces. There's the pressure that's inside the cylinder, and then there's the stresses within the material that's resisting that expansion of the pressure inside, right? So the two forces that we have here is the pressure, which is acting on that blue slice, I guess you can call it, the blue area, and then the resistive stresses are the stress in the hoop that are just within that thin layer here of the material. So the stress, the hoop stress, we sum the forces, make them equal to 0. So we have the stress in hoop minus the internal pressure, and those have to be equal to 0 here. So the stress in the hoop is just the thickness, right, which is T, right, just that thickness times the length, which is delta X. So it's T times delta X, but we have 2 of them. So it's 2, so the stress in the hoop is equal to 2 times delta X times the thickness. That's the cross-sectional area of the stress on the thin wall. And then on the other side, you have the pressure. And, I'm sorry, so we have to take that. This is the force in the hoop, is the cross-sectional area, which is A, times the stress in the hoop. So we're going to multiply by sigma H here. So this is area times the stress times the area right here. So that's the force in the hoop. And then the force due to the pressure inside is this area here. So it's delta X times 2 times the radius. Delta X times 2 times the radius. So that's the area. So 2 times the radius, delta X. And then this is times P, pressure. So now we have the two equations here. We sum them, make them equal to each other, right? So that means we have, we just rewrite this, sigma H times 2 delta X T is equal to pressure times 2R delta X. Are equal. So then I'm going to solve for the hoop. So that means it's going to be pressure times 2R delta X over 2T delta X. So the delta X's cancel out, the 2's cancel out, and we're left with PR over T. So the stresses in the hoop are pressure times the radius over T. So now we're going to do the same calculation for the hoop for the longitudinal stresses. Okay, do that same for the longitudinal stresses. Okay, so for the longitudinal stresses, we're looking at a slice, perpendicular to the cylinder like this. And now we have the pressure force, which is basically the end caps. So the end caps, the pressure is acting on the end caps of the cylinder, and it's causing it to like lengthen, right? And so that is the blue area here. That's going to be the area of the end caps. So if we look at the pressure that's acting on that, so the force is P times area. So that's area here, which is going to be pi r squared. So that is the force due to the pressure that's inside, right? And then the resulting force, or the resisting force, I'm sorry, from that is going to be the force from the longitudinal direction, and that's going to be the sigma times the stress in the longitudinal direction, which is that, times the area. So now we just want to look at the area of just the slice through the pipe or cylinder, whatever you want to call it. So that's just the circumference times the thickness. So it's just the circumference times the thickness. So circumference is what? It's 2 pi r is equation for circumference. Multiply that by t. So this is going to be our area right here. So now we just sum these two, or make them equal to 0, right? So we just have P pi r squared is equal to sigma L times 2 pi r t. And so solve for sigma L, our longitudinal. So that means we just have P pi r squared over 2 pi r t. Pi's cancel out, one of the r's cancel out, and we're left with P r over 2t. So this is the hoop stresses, and then this is the longitudinal stress. Notice the only difference here is the 2 in the denominator. So that means that this is half, right? The longitudinal stresses are half the stresses in the hoop. So that's derivation. Any questions?